Hello everyone, welcome to my channel. So today we are going to talk about Lombok, and this entire video is going to be all about Lombok. So in this video what we are going to do is we are going to write down the code using Lombok library and see what it actually does internally so that we can actually see what it is all about. So before we move on to this video, if you are new to my channel, if you haven't subscribed to my channel yet, please do. Now let's see the code and let's talk about Lombok. Alright, so first thing first, what is Lombok? So Lombok is an annotation based library that enables you to write less boilerplate code. Several annotations provided by Lombok are intended to replace Java code, which is infamous for being boilerplate, repetitive, or time consuming to create. So in simpler terms, whatever we write in our Pojo classes, let's say our setter, getters, constructors, which could be your no argument constructor, argumented constructor, and your toString method, maybe hashcode and equals method. So these are being considered as boilerplate code because every Pojo class is going to have these things. And if we are writing these things in each and every Pojo class, then we are adding repetitive code to it, right? So it could be like there are different logic for your hashcode and equals method, but sometimes we want something common for all of these Pojo classes. So this is the library for this task. Like if you want to reduce that boilerplate code, then you can do it with Lombok. So there are annotations with Lombok because it's all about annotations, but there are some common annotations that are frequently being used. So some of them or all of them I think are here. If I missed out few, then do let me know in the comment section. So these are the ones that I thought that we are frequently using, and I will talk all about this with the code also, so don't worry too much about it right now. Then there are some advanced annotations which we don't frequently use, but they are there, so you should know about it. So these are the ones that I consider advanced annotations because with synchronization, with logging, sometimes things get tricky, so we may want to use it, or maybe we just want to add our own code, right? So it totally depends on a developer, but this is what we are going to talk about. So first we will look at the common annotations and then we will slowly move towards advanced annotations. So let's start with the code. Alright, so first thing first, you need to create a new project. So I'll just click on this and I'll just give a simple name. Alright, so I will be using Java 17 here with Maven. So once your project is done loading, then what we need to do is we need to make some changes to our pom.xml file. Now, like I said, Lombok is a library, so we have to add it to our project first. So I'll go to the Maven Central, and here I can see that the latest version is this one, and it is being used by a lot of people. So let's choose this one. Let's copy this. So here we don't have the dependencies tag, so let's first add that. Paste our dependency here, save it. So it should be generating the library for us, and if it doesn't, then let's go to build, resync. Alright, so now I can see that the library is added. So let's create a new Pojo class. So I'll just name this Pojo with common annotation. It's a big name, I know, but let's do it. Now I will have some variables because our Pojo class always have variables, right? So first we will have an ID, then let's say name, then lastly let's add email also. Alright, so what I want is I want getters and setters to be generated, and before that I need a no argument constructor, then I need all argument constructor. Then I simply need a toString method. So this is the agenda for now, and then we will slowly add more and more annotation to this. So now to add a new constructor with no arguments, we just have to use the annotation which we have already seen, no args constructor, right? So I'll just add this for now, but as you can see that this annotation is being used, but the code is not here, right? So how does Lombok generates that code? So once it is done compiling, like before it is running your code, then it usually adds the code, that boilerplate code, to your Pojo class, right? And then it gets executed. So if you want to see what this annotation is actually adding to your Pojo class, then you need a plugin into your IntelliJ which is dlombok. So you just have to add that. It's a simple installation, it's not a big thing. So you just have to right click on your class, go to refactor, and then you can see dlombok here. So I'll just do all Lombok annotations, but currently I'm having only one annotation, so it's a good habit. So here you can see that the constructor is created for me and there is no argument. So this is what I wanted, and here right now you don't see any annotations, right? So this is your Pojo class which will get generated before running your code. Alright, so let's move back. Now I also want to add all argument constructor. Now again I will check with dlombok if I have that. So here you can see that I have that with all the variables that I wanted, right? Now this is this. Now let's move back and add everything to it. So now I need setters, getters, and my toString method. Alright, so now let's generate the code. So here you can see that our first constructor is argumented, another one is no argumented, then we have getter methods first, then our setter methods, and then we have our the toString method with everything aligned, right? So good to go till now. Now what if I don't want to generate the setter and getters method for each and every field? I just want to add it for a few. Then what should I do? So simple thing is, don't add it to your entire class, right? So here I'm using, let's say, getter annotation, and let's say that I'm not using setter method for each and every variable, right? So I'll just remove it from here, and let's say that for ID I don't want it to be set, so I won't use the setter annotation for this. I'll just use it for these two. So I can do it like this. Now I know that you can imagine what will happen if I generate this code, but just for the sake of clarity, so here what is happening, we have getter methods for all of the variables, but for setter methods I only have name and email. There is no setter method for your ID. So this is what we wanted. Now this is all about setter and getters. Now what if I don't want to have an all argumented constructor? I just want to have for few of the variables but not all, right? So now what should I do? So previously we used to have some argument constructor, but that is not the case with the newer versions now. So with this we can have it for not all but few of our argument. So now what should we do? So now there is another alternate, which is to not use all arg constructor but required args constructor. So for this what happens is it will only generate the constructor using argument which are either annotated with your not null annotation or they are final keyword variable, sorry, right? So let's try that. So here let's say that I'm annotating this with not null. Let's leave this one. I don't want this to be in my constructor, right? So let's skip this one. So this is not null, sorry, it's not, it's non-null, my bad, right? And let's keep this one as final. So here I have a non-null variable and here I have a final variable. So if I generate this, so here you can see that I have a constructor with name and email. So it only took the variables with either non-null annotation or with your final keyword, right? And then I have my no argumented constructor. So there is one more way. So if I use my previous annotation, which was all argumented constructor, so it doesn't takes care of the final keyworded variable. It means that if you have a final variable, then all argument constructor annotation will not pick it up. So here I will just remove this. So here let's initialize this to default. And now if I generate the code for this, what I am expecting is that it should only take care of these two as an argument and leave this one out, right? So let's run this. So yeah, here I can see that it only took ID and name as arguments and left email, and that is good. That is what we wanted. So it is not like we are going to have this logic in our real case scenario, but it should always be good if we learn about some failsafe or some specific scenarios also, right? Because we are learning about a new library, so why not? Now what we have covered is we have covered no argumented constructor, all argumented constructor, and then we also covered required argumented constructor. Then we looked at getters and setters and toString methods. And with toString method actually we can also exclude, like what we were doing with getters and setters, we can do that for toString also. So like I don't want this ID to be populated with my toString method, I just need to take care of these two. So what should we do in that case? So let's take a look at that. So here we are going to use the same annotation toString, but there is this property with this. So here either you can say exclude or include. So I just wanted to exclude, so I will just do this. And now if I generate the code, so here I can see that in my toString method I don't have get ID, right? So this is how you can do it with your exclude properties, right? And then you can play around with exclude and include both. Now let's move ahead. Now we will see equals and hashcode annotation. So equals and hashcode annotation generates the implementation for your equals and hashcode method. But the good thing about this is if I use this, let's use this. So again it is going to use each and every variable of yours. So let's remove this one, and now the implementation of your hashcode and equals method is going to be really good. This isn't something that I expected from Lombok library, but it is actually pretty good. So if I generate the code, so here if you see the equals implementation, you can see that it is pretty big, right? This isn't what someone can expect. And then I have can equal implementation also. Then in hashcode I can see that it is pretty good implementation. So you can depend on it if you want, because I recommend it, and it doesn't matter if I recommend it or not, but if you like it, then yeah, please use it. But I'm using it, so that's why I recommended it. So it's pretty good. Like if you want to use some dummy implementation, yeah, then you will have it. So one thing to notice about your equals and hashcode method is that it is by default going to use your non-static and non-transient fields to generate equals and hashcode methods. So let's say that I'm making this one static, and this one as transient. So now things are going to get changed. So here in my hashcode method, I only see that my id variable is only being used, and same goes for equals method. So previously you can compare it also, that it was a big implementation for equals method. Now it is pretty small. Now again, what will happen if, let's say, I don't want to have static and transient fields, but I want to exclude these two from my implementation? So what will you do in that case? So like we did for our toString method or annotation, similarly we will do something like exclude, right? So I'll just exclude it, and let's see now. So here again you can see that it is pretty much exactly similar to what we did before, but now we don't have any static or transient variable, right? So this is another way. Now if you have a super class of your Pojo class, then you can use call super properties, something like this. So what will happen is, here if we are having a super class, then in that case we can include the equals and hashcode methods of our super class in the generated methods. So in this case, super class has to override equals and hashcode methods, and user may have different equals method implementation. So this is that. You can play around with it. I don't want to like make confusion to provide too much information, so I'm just gonna leave it to be. But yeah, this is a great feature also. So if you have some time, if you want to explore more, then yeah, you can use it. Now what did we leave? We covered getter, setter, arguments, constructor, all of them, toString. So now we are only left with data and value annotation, right? So these are pretty good annotation which I really like, and these helps a lot. Now data annotation is similar to what we have seen in Spring Boot framework also. So if you are familiar with Spring Boot, we have there an annotation named Spring Boot application annotation, which is a very famous, or you can say a big annotation in Spring Boot framework, because this annotation allows us to not have multiple annotation in our class, rather just have a single annotation which is like a combination of 3 annotations. So that is how data annotation is also in the play. So with data annotation we don't have to provide multiple annotation, because data annotation is a combination of few which we frequently uses. Now what is that combination? So data annotation is a combination of toString, your equals and hashcode annotation, your getter, setter annotation, and lastly it also have a required argument constructor annotation. So we have already seen required argument constructor annotation with a brief example. So here you can have these two, right? And for these, all of them, we can have the data annotation, right? But I'm going to remove all of them so that we can get the clear picture to what it actually does. So here if I just add a data annotation, so here we will get toString, equals and hashcode, getter and setter. But for required argument constructor, as I have already told before, for this either the parameters or variable have to be non-null or final, right? So here we have to do that. So I'm not going to make all of them as non-null or final. I will just keep these two as non-null for an example. So if I do that, I'm expecting that these two will appear in my required argumented constructor, right? So let's try to generate. So now here what we see a constructor with name and email, which is what we wanted, and we got a required argument constructor here. We got getters here, and then we got setters here. We got equals method as well as hashcode method. Then lastly we have our toString method also. So it achieves all of them. Now value annotation is also similar to what we have achieved with data annotation. The only difference is that this value annotation is like an immutable variant of your data annotation. So remember, there is a terminology which is really popular in your interview questions also, immutable classes. So for these we can have value annotation. Now again, value annotation is a combination of your toString, equals, and hashcode method, similarly like your data method. But if we were to talk about an example, so in a typical immutable class, what we see that this class should be final, the variables should be final, right? That is the case, but here we don't have that, right? I can remove this not null, non-null. So here I don't have final for any of them, right? So I'll just change this annotation to value. Now if I generate the code, so here what do you see? You see that this class is now final, the variables are final, right? That is how it is helping us to make immutable classes or immutable functionality. And one more thing to notice is that here we got an all argumented constructor, and if you remember, with data we only get a required argument constructor, which means that your variable should be either non-null or final. And one last important thing is, in immutable classes we don't have any setter methods. So we here have getter methods, but we don't have any setter methods. So this is what we can achieve with our value annotation. Now these were your pretty common or frequently used annotation. Now let's move towards advanced annotations. So in advanced annotations we have these 5 to cover today, so let's quickly do that. Okay, so talking about cleanup is like your Java 7 feature which came with your automatic resource management, auto resource management. That is what we can achieve with our cleanup annotation. So to use it, I'm going to remove everything from here. So what we are going to do here is, let's add a main method. So what I'm going to do is, I'm going to use an input stream and output stream just for the sake of an example. So what I will do is, I will have, let's put stream. So with streams, what we have to do, we have to open them and then we have to close them, right? So that is what comes under our resource management, because if we don't close it, then it is going to remain open and take your memory, which isn't something that you want, right? Because so garbage collection is not going to work here, because the memory is being occupied. So if in case your application requires a new memory portion, then it will not get it because you are consuming it. And if you have a lot of streams open, then that is a pain, right? So that is how we always say we have to maintain our resources. So here let's say I will provide something in my argument while running the code, and here it will throw an exception. So let's do that. Now again, output stream, and if you can see here, I haven't done anything for cleanup, right? Because I want to show an example of before that and then afterwards. So what is going to happen? I have opened two streams. One is input stream and another one is output stream. And as I have opened, if I complete this execution, these two will always be in your memory because they haven't been closed yet, right? So to close it, what we do basically, let's say if there is some part of code here, so what will I do is, I will just do in dot close and then out dot close, and again this will have another exception. So this is what we have to do, right? But with Java 7 we got this, that you can do it in your try block, right? So let me remove this and let's comment these out, and let's say if I want to open it, so I will just open it here, and in this case what I can do, I can add a catch block. Alright, so in that case I don't have to do in.close and out.close. So this is what came with our Java 7. Right, now what we can achieve with Lombok here. So as we can see here, there is too much to write. So to reduce that part of code, I'll just remove everything from here because we don't need that. And again, I don't have to do anything because Lombok is an annotation based library. So what do? We just have an annotation which is cleanup. So once we are done with our portion, this will actually clean up the code. So this isn't doing anything new. It is just doing the same stuff which we have to do if we are not using any annotation. So somehow I'm not able to generate this part of code, but I can assure you that behind the scenes it is actually doing the same thing, which is your in.close and out.close. But that is being done in your finally block because that's where we do that usually. If in case there is some kind of exception, then finally block always gets executed. So there isn't any risk for that. So that's why we are closing our resources there only, right? So this is about cleanup. Now let's move to our new annotation, which is synchronized. Now synchronization is very famous when we talk about multi-threading. So synchronized keyword is what we used to do or we used to use. So synchronized block and your synchronized keyword, right? These are the most frequently ones that we use with multi-threading. So here with Lombok we get synchronized annotation to achieve the same. Now let's say that we have an object which we want to have a lock on, right? Let's say for read access, for write access, or for both. That depends on us, right? So we can use synchronized keyword for that very same purpose. So here we are going to use Lombok annotation, which is again of the same name, synchronized. So here let's say that I want to lock on my ID variable. So what will I do here is I will have, let's say, a method, let's say get set go, and I'm not doing anything. I'm just going to do hello, right? I think just rubbish as of now. So what I'm going to do here is for this method access, I'm going to use my synchronized annotation, but this is going to have a lock on my variable ID, right? So this is how you can do it, or you can simply have a lock like this, right? So this is a way to achieve synchronization. Now I'm not going too deep into it. Again, there are more variations to it, but remember that here I'm going to provide you a simple start so that you can have a base to work on, and then you have to work on it yourself because every scenario is different. Whatever code you are going to write is going to be different than mine. So you should have a basic knowledge and then you can slowly move towards in-depth knowledge. Now talking about sneaky throws. So sneaky throws annotation is to throw checked exceptions without actually declaring this in your method, right? So we have already seen that example. So here if you see, file not found exception is a type of your checked exception. So here we are going to do our sneaky throws annotations. So here if I just cut this out, remove it from here, what will I have to do? I have to just do sneaky throws, something like this. So it doesn't reduces much, but again this is a variation of how you can use annotation here. And in case you have a method where you are just using throw keyword, so let's say public void test. So in that case, let's say I'm just throwing an exception. So in that case I can just do sneaky throws. So that is one more variation that you can do, right? Now builder annotation and then log. So builder annotation produces the code automatically using builder pattern. So that is why the name builder. So I'll just show a basic example. I'll just try to make it simple, but let's see if I can do that. So I will remove this because we don't need this part of code. So let's do that. And here what I will do is I will just add build annotation here. So if I just generate the code and then I'll explain. So here what do we get? We got an all argument constructor, then we got a static method which is to return a new instance, and then we got a static class with the same variables. Here we have no argument constructor, and then we have these methods which are just returning another instances, and then we have toString method. So I'm not going to go deep into it, as I have already said that this is completely based on your builder design pattern, so you have to be aware about builder design pattern. But in case of annotations part, you can see that this is what we get out of it if we try to generate the code, right? So if we see what is happening behind the scenes, this is what is getting generated, another static class and a lot of things, right? So again, I won't go much deep into it because this video is going longer and longer. So yeah, so if in case you require that knowledge or part of video, then do let me know. I will try to make another one. Now let's move towards log annotation. So with log annotation, you don't just get log annotation, you get commons log, you get SLF4J log, you get your custom log, JBoss log. So there are a lot of annotations, and then what you can do is with custom log, if you have something of your own, then yeah, you can provide that too. So it's a whole new set of annotations with your log annotation. And again, I won't be able to do that because this video is getting longer. So what I will do is I'll just give you a brief of each annotation. Alright, with commons log, what do we get? We can create private static final instance of your log file, right? And with flogger, everything is similar, but you are using another library which is of your Google. This one was of Apache. Similarly for JBoss is same. Here for log annotation, you get something like that. So here it totally depends on your choice of what library framework, log framework are you going to use, right? So that's that. And then for your custom log, you can have your own log example or class, and then you can create your own logger with logger factory. You can append that, and then you can create an instance of that. So this is all about the advanced annotation. I know that I haven't done much to represent these advanced annotations, because I know if you are trying to learn a new library, you are not going to go directly at your advanced annotation. You are going to start with your basic annotations. And as I have already used Lombok, I know that you are going to start with and are going to frequently use your common annotations only. Advanced annotations are very specific, so you are not going to use those annotations in a lot of scenarios, right? So this is all about Lombok, and I really hope that you liked what I have represented here. So if you did, don't forget to like this video, share this video if you have something to show off or show off to, and subscribe to my channel if you haven't yet. So this is it for this video. I really hope that we will meet in some another video. Till then, have a good day, stay safe, and bye bye.